Hello and welcome back to Algebra. Here we are once again having a good time. Chapter 2, Section 6, Absolute Value Inequalities. Alright, solving absolute value inequalities. Let's first look back at solving an absolute value equation. Remember that this meant I had to solve for x equals negative 2 or x equals 2, because there's two cases. If I plug in negative 2 here, absolute value is 2. Plug in positive 2, absolute value is 2. So we have 0 here, negative 2 here, and 2 there. Then my solution there was just a dot at negative 2 and 1 at 2. That's the distance, how far it's away. Now, it says the absolute value is less than 2. So again, I'd have to solve for two cases. Either the positive case, where we just drop the absolute value bars, x is less than 2, or the other case, where we have negative 2. Now, if we have the negative, we have to flip this around, because we changed this sign here to a negative. It's like we're multiplying by a negative. We have to flip that sign. X is greater than negative 2. So open circle here, open circle there. X is greater than negative 2, and x is less than positive 2. So I could have also written this statement, since it's turned out to be an AND statement, negative 2 less than x, which is less than 2. Up here, x is greater than 2, so again I have the option of the positive. X is greater than 2. There's 0, negative 2. Open circle this way. Or I have to do the negative case, where x is, flip the sign around, less than negative 2. This is an OR statement. Okay, so I could write this. X is less than negative 2, or x is greater than 2. Alright, here's an example solving absolute value inequalities. Solve and graph. Alright, we have to do two cases. Now, since it's less than, that means it's an AND case, so I can set this one up as the positive case or the negative case all in one. So I can do the negative 2 over here, less than or equal x plus 7 in the middle, and then less than or equal to positive 2. Then I can solve the whole thing in one. Subtract 7 from each side, and I get negative 9 less than or equal to x less than or equal to negative 5. That's a closed circle. 5, negative 9, closed circle. And since it's less than, that's an AND statement, that's in between. Alright. 8x minus 11 is less than 0. Is it possible for an absolute value to be less than 0? No, that would mean it'd have to be a negative number, and this can't ever come out to be a negative number because it's an absolute value, so this is always going to be positive, so there's no solution to this. This is not possible. Alright, solving absolute value inequalities. Here we have a greater than example. So, c minus 1 is greater than or equal to 5. Greater than is going to go to the outsides, so that's an OR statement. We have to solve the positive and the negative situation. Negative means we flip the sign, less than or equal to negative 5. Positive, we just solve this as it is. That is an OR statement. Solve each of these by adding 1 to each side. C is less than or equal to negative 4. Closed circle at negative 4, less than, goes this way, plus 1 here, C is greater than or equal to 6. Find 6, open circle, greater than. Because it's either this or it's that, which means the distance from this number, right, from, well, -1, from this number is greater than 5. So from that number 1, right here, from this number, the distance is greater than 5. So everything outside of there. Okay, here this is saying the distance from this is greater than -2. Okay, so an absolute value, remember, is always going to be positive. Doesn't matter what number we plug in here, it's always going to be true. It's always going to be greater than -2. So, in this case, this is the graph because it's all real numbers. It's always going to be greater than a negative number. Alright, and then we have this fun little situation. Remember, always isolate your absolute value first. That means get this by itself. Alright, so subtract 1 from each side. We get 4 times 2x minus 5 is greater than 20. Divide each side by 4 to get the absolute value by itself. That's our first step. 2x minus 5 is greater than 5, the absolute value of this. Now I can solve my two cases. So I either have 2x minus 5 is greater than 5, or 2x minus 5 is less than -5. Flip both signs. Alright, solve each case, add 5. And we get 2x is greater than 10, or 2x is less than 0. Divide by 2. And we get x is greater than 5, or x is less than 0. So open circle, less than 0, open circle, greater than 5. Alright, absolute deviation is the distance from a given value. So you've seen a similar formula when we were doing absolute value. We have x minus that, it was the middle number, right? And then this was the distance. In this case, we call it absolute deviation. So to deviate means how far it's away from something. You're buying a new computer. The table shows the prices of computers in a store. You're willing to pay the mean price with an absolute deviation of at most, you need to know what that means, at most $100. How many of the computer prices meet your condition? So how many of the computer prices fall within $100 of the mean? So first we find the mean, so we add all these up, tally them all up, and then divide by 10. So add it up, all of these add up to 6,640. Divide that by 10 because there are 10 different prices, and we get 664. Now, question is, which ones are within 100 of this? So we're looking for the absolute deviation. Remember, absolute deviation is x minus a given price, so x minus this 664. The absolute value of that has to be at most 100. Okay, so we're going to have 100 over here. At most means less than or equal to. So it has to be within that range. Alright, so I can set this up. Since it's less than, remember that's an AND statement because it's going to go from one price to the other. It's going to be on the inside of those two. So I can set this up with my -100 over here, and then x minus 664 in the middle, and then 100 here. Solve on each side, plus 664. And we get, let's move this, move that down there. There we go. And we get 564. 4. 4s are difficult with this board. Is less than or equal to x, which is less than or equal to 764. And now we, oh dear, there we go. So the prices have to fall in this range. They have to be greater than or equal to 564. So anything less than 564 is out of the running. Okay, and less than or equal to 764. So this is out of the running. This is out. All right, so it's 1, 2, 3, 4, 5, 6. 6 of the computer prices meet the condition. All right, that was absolute value inequalities. Remember, if it's less than, the distance is less than 2 from a certain number, so it's within that range. If it's an AND statement, if it's greater than, that means it's on the outside of that. It's further away from that particular number, so it's an OR statement. And that was all. Check back again next time for a fun lesson. And of course, remember to like and subscribe. Have a lovely day.